Alright, for 42, they're asking you to use either A, B, or C to solve 48 squared. So for 42, I'm using B because you have a choice of using A, B, or C, so I'm using B. The x minus y, that quantity squared. So what I'm going to break up 48, or I'm going to rewrite it as 50 minus 2 squared, right? That's still 48 squared. But now I'm going to use that formula in B, and which says it's x squared. So this is what it says. It says x squared minus 2xy plus y squared. So x is 50, so that's 50 squared, minus 2 times 50 times y, y is 2, and then plus 2 squared. So this gives me 2500, okay, minus 200 plus 4. So that's 2300, 2300 plus 4. So that's 2304. Okay, for number 43, they want you to find 62 squared. So for this one, I'm going to use A, that says x plus y squared equals x squared plus 2xy plus y squared. Oops, that line shouldn't be there. So I'm gonna break up the 60 as 60 plus 2 squared, okay? Because that's still 62 squared. So that's gonna give me 3600, because 60 times 60, plus 2 times 60 times 2 plus 2 squared. So 3600 plus 240 plus 4. So the answer would be 3,844. So for 44, use the picture in the handout. This one came out really, really bad, as you can see. But I wanted to draw it anyway to kind of point out the different parts that I'm using. But these triangles are supposed to be congruent. Okay, they're all the same size. I know they don't look like it on my drawing, but if you look at the paper, they are. And this is a square. Okay, so this big square here is the dimensions of the sides, or the length of the sides is C, equal to C. So the big square, if I look at the whole square, it's C squared. But it's made up of 4 triangles plus 1 small square. Okay? It's four triangles and 1 small square. So the 4 triangles have this dimension. They all have a base of B, and then they all have a height of A. So think about it. I have 4 triangles, and the area for a triangle is 1/2 the base times the height. The height in this case is A. Okay? Now the small square has, you have to figure out the dimension for the small square, right? So the small square is, let me change the color. This length right here is A, right? Okay. And this length right here, let me highlight a different color. This one that I'm highlighting in blue, from here to here is B, right? Because these triangles are all congruent. So the dimension of the triangle, or the length of the, of the square, this one right here would be A minus B, right? That's what we have here. That's what's missing. So it's A from here to here, it's B from here to here, so that means that this one right here is A minus B. So A minus B squared, because it's a square. That's the small square. So now let me work out. So 4 times 1/2 is 2. BA, we usually write it in alphabetical order, so I'll write it as AB. And over here, I have a squared minus 2ab plus b squared. Now combine like terms, so notice how this is a plus 2ab and this is a minus 2ab, so they cancel out. So then we have c squared equals a squared plus b squared, which is Pythagorean's theorem. For 45, it's asking you, why is it important to know whether a function is one-to-one? Well, it helps to know if it's one-to-one because you know that one-to-one functions, so one-to-one functions have an inverse function. Okay, many to one functions do not, so that's why it's important to know whether it's one-to-one.